We now discuss the solution of a problem from the section Integral Calculus. The problem is on integration. This question has appeared in the joint entrance examination main held on 26th June 2022 in the second shift. This question is also suitable for all those students who are writing the Telangana State MSET examination and Andhra Pradesh State EAP CET examination. The given question is, if integral 1 by x multiplied by under the square root of 1 minus x by 1 plus x dx is equal to g of x plus c, and g at x is equal to 1 is equal to 0, then g at x is equal to 1 by 2 is equal to, we are given four options. Option A, option B, option C, option D. Agreed. Now we are given the integral of this function is g of x plus c, and given the value of g when x is equal to 1 is 0, required to find the value of g when x is equal to 1 by 2. We now discuss the solution of the problem in detail. So we are given the integral of this function is equal to g of x plus c. Given the value of g when x is equal to 1 is 0, we want to find the value of g when x is equal to 1 by 2. Now the integral of 1 by x multiplied by under the square root of 1 minus x by 1 plus x with respect to x is equal to g of x plus c will tell you that when we integrate this function, we get g of x, where c is the constant of integration. Now, g of 1 is known to us, is given to us, and to find g of half. So, we will integrate this function between the limits x is equal to 1 by 2 to x is equal to 1. That means we will write this as a definite integral from x is equal to 1 by 2 to 1. And this is integral x is equal to 1 by 2 to 1 of this function with respect to x is equal to, when you integrate this, it's already given to us that it is g of x, and that is to be evaluated between the limits x is equal to 1 by 2 to 1. And while integration, we do not find any difficulties in the integration part. Why? Because the path of the integration, or the domain, that is the integration, is taking place from x is equal to 1 by 2 to 1, and in this x is equal to 0 is not there, x is equal to minus 1 is not there. So therefore we do not find any difficulty in the integration of this. The integral exists. Good. So when integrated is g of x when x is equal to 1 by 2 to 1, and that is g of x for the upper limit x is equal to 1, g of 1 minus g of for the lower limit g of half. But we know g of 1 is given to be 0. So this will be equal to the integral of 1 by 2 to 1 by x under the square root of 1 minus x square 1 plus x with respect to x is minus g at x is equal to 1 by 2, because g of 1 is given to be 0. So we got g of half. The value of g at when x is equal to 1 by 2 is this one with a minus sign. So the value of g when x is equal to 1 by 2 is equal to minus the integral 1 by 2 to 1 of 1 by x under the square root of 1 minus x square 1 plus x dx. So find this integral. The value of this integral will be g of 1 by 2. Right. The problem is reduced to the computation of the evaluation of this definite integral. To evaluate this one, put x is equal to cos 2 theta. We are looking at under the square root of 1 minus s square 1 plus x. So we take x is equal to cos 2 theta, and the derivative d of x is equal to derivative of cos 2 theta minus sin 2 theta. 2 theta with respect to theta is 2. So dx will be minus 2 sin 2 theta d theta. Now what happens to the limits? So when x is equal to 1 by 2, cos 2 theta will be 1 by 2. So 2 theta will be cos inverse 1 by 2. Cos inverse 1 by 2 is pi by 3. Therefore theta is equal to pi by 6. And when x is equal to 1, cos 2 theta is 1. 2 theta is cos inverse 1, that is 0. Therefore theta is 0. Agreed. So the above equation will become, the value of g when x is equal to 1 by 2 is equal to minus integral for 1 by 2 pi by 6 to, for x is equal to 1, 0 of 1 by x is cos 2 theta under the square root of 1 minus x is cos 2 theta by 1 plus x, 1 plus cos 2 theta, and dx is minus 2 sin 2 theta d theta. Agreed. So the integration part we will see in the next slide. That's what we have brought forward here. Now we want to change this integral from pi by 6 to 0 to pi by 6. That means we want to interchange this upper and lower limits. To do so, we have to multiply by minus 1. So here is a minus 1. By interchange, we will get a minus 1, and there is already a minus 1. There are 3 minuses. Therefore, the result will be minus, and 2 is taken common, minus 2. The integral 0 to pi by 6, 1 by cos 2 theta into under the square root of 1 minus cos 2 theta is 2 sin square theta by 1 plus cos 2 theta is 2 cos square theta. So 2 cancels. It is sin theta by cos theta, that is tan theta. For sin 2 theta, we have written sin theta into cos theta. 2 times sin theta into cos theta with respect to theta. Tan theta we have written sin theta by cos theta cancels. You will get a 2 sin theta into sin theta, that is 2 sin square theta. So that will be equal to minus 2 integral 0 to pi by 6 1 by cos 2 theta into 2 sin square theta with respect to theta. Agreed. For 2 sin square theta, we will write 1 minus cos 2 theta. So that will be equal to minus 2 into integral 0 to pi by 6 1 minus cos 2 theta by cos 2 theta with respect to theta. So that will be equal to minus 2 into integral 0 to pi by 6 1 by cos 2 theta is secant 2 theta minus 2 into integral 0 to pi by 6 secant 2 theta minus 2 into minus, that is plus 2 into integral 0 to pi by 6 cos 2 theta by cos 2 theta, that is 1 d theta, that is d theta. So that's what we got it. And now we integrate. That is equal to integral minus 2, and we know the integral of secant theta d theta, but here it is secant 2 theta. So the integral is ln logarithm of mod of secant 2 theta plus tan 2 theta to be evaluated between 0 to pi by 6 by 2 theta with respect to theta differential, that is 2 by 2, that is what we have written is 1 by 2 because of the 2 theta, plus 2 into integral of 0 to pi by 6 d theta is theta only. Theta when evaluated 0 to pi by 6 is pi by 6. So 2 into pi by 6. And this 2 cancels, and 2 ones are 2, 2 3s are 6. So you will get minus 1 into logarithm of secant 2 theta for the upper limit. So theta is pi by 6, 2 theta is pi by 3. So logarithm of secant mod of secant of pi by 3 plus tan pi by 3 minus ln of mod of secant 0 plus tan 0. Secant 0 is 1, tan 0 is 0. So you will get ln of 1. So minus ln of 1 plus 2 into pi by 6 is pi by 3. So ln of 1 is 0. And this will be equal to minus 1 into logarithm ln of mod of secant pi by 3 is 1 by cos pi by 3, that is 2. So 1 by 2, that is 2, plus tan pi by 3 is root 3. Yes, these results are very well known to us. Plus pi by 3. Plus pi by 3. Which one? ln is 0. So tan pi by 3 is root 3. ln is 0. And this pi by 3 is here. So this is this minus 1 taken inside the logarithm. And that is equal to ln of mod of 2 plus root 3 to the power of minus 1. That is equal to ln of 1 by 2 plus root 3 plus pi by 3. So this is our now. Yes. We will rationalize the denominator. To do so, we multiply and divide by 2 minus root 3. So 2 minus root 3 by 2 plus root 3 into 2 minus root 3, that is 4 minus 3, that is 1. So that will be ln of 2 minus root 3 plus pi by 3. That's our answer. Let's look at our options. And in all our options, we have root 3 minus 1 by root 3 plus 1 or root 3 plus 1 by root 3 minus 1. And of course, we got the pi by 3. So plus pi by 3, therefore the answer is there in A or B. But you look at A and root 3 minus 1 by root 3 plus 1, rationalize the denominator, then you will multiply and divide by root 3 minus 1. So when multiplied in the denominator, root 3 minus 1 into root 3 plus 1 is 3 minus 1, that is equal to 2. And the above root 3 minus 1 whole square. Root 3 minus 1 whole square is root 3 minus 1 whole square by 2 is 2 minus root 3. So this is equal to ln of mod of root 3 minus 1 by root 3 plus 1 plus pi by 3. And this answer appears against option A. Agreed? Therefore, our answer is option A. So that is the detailed discussion of the solution of the problem from the section integral calculus, and it is on a definite integration. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.